Hi, everyone. I'm going to go over a topic that I think is somewhat underappreciated, let's say, in terms of this whole design process. Everyone wants to jump into the technology. Everyone thinks, hey, well, we can figure out humans and then just magically apply that onto the technology, or we have to worry about the complexity of an algorithm that we're dealing with, or whatever the case is. But the task itself seems to be the thing that a lot of people overlook. And it's one of the harder things to get right. And I will be arguing with many of you throughout your entire course project about this. So let me be very clear about what we're trying to do here. Last time when we were looking at things, we looked at data, data sets, and attributes. And we looked at how we could break down. We have a bunch of data. How do we analyze it? How do we figure out how do we categorize it into different types? And those different types of those different categorizations ultimately dictate how we will actually either visualize it or analyze it, what kind of stats we can use, that sort of thing. Also, just as an aside, that categorization and that analysis allows us to figure out how we can convert from one type to another. So if we have unstructured data, just say it's text and there's no real rhyme or reason to that text, it'll tell us how we clean the text, because if all that text has to be numbers in quotes, then we need to be able to convert from text to a number, right? And if you give me not applicable, I have to remove that data item or put a zero or something like that. If there's only a certain number of categories and you give me a completely different category, that would be different as well. So if I say, tell me your home country, and you write down right here as the name of your home country, that's bad data and we would have to change that, right? That's part of the cleanup process. And if it's purely unstructured and we can't convert it to this other format, then we got a different problem and we need to solve that first. Also breaking down what kind of data we have, so whether it's structured, unstructured, what kind of data set it is, if it's continuous data as well, what data sets we have, or data types we have, all of how we define these attributes that we have for our data, all ultimately also dictate how we explore the data, how we analyze the data, what we get to use. I was going to go something else on this particular thing, so let me think about that. So what we're going to be doing soon. Oh, it also tells us how we can break if I have data that is sampled at a somewhat unknown interval. How do I interpolate data based off of the interval of sampling that we have? And that's what we did when we talked about continuous grids. All of this, understanding the data breaks it down into a chunk. It is part of the first step, much like when you don't just start coding, you think about your design first. Much like that, we don't just start willy-nilly making visualizations or willy-nilly just typing things into Python. We plan out what the data looks like. We plan out how everything looks and clean things up. We think about what the approach should be before we dive in. It is something I struggle with. It may be something you guys struggle with as well. That methodical planning, which is key to any kind of data analysis, is key to any kind of data analysis. It's not something you can overlook. It's not something you can skip. Okay. So this is what we looked at last time, and then we even looked at attribute types, and we talked about like categorical data, ordinal data, continuous quantitative data. So we have continuous, and we have discrete data, all of which are quantitative data. And we have different analysis based on that. When we look at stats, we're going to look at this again. I like to point out here in Bostock's 2010 paper. It's related to Cleveland and McGill's results from 82, 76, something like that. Oh, I got to look it up again. This is one of those research papers that keep on being analyzed over and over again. These are classics in the field, if you will, where what you do is you give people a bunch of different ways of representing the exact same data in some kind of graphical format, and you ask them and you see if how off they are, what kind of error they have, how fast they answer, that sort of thing. And in this case, they were looking at the amount of error that people make when it comes to looking at these different visual representations of data. What was interesting about these papers is that, so they had a whole bunch of different ways of doing position in this case. The here in Bostock one was actually using what's called a mechanical Turk. So Amazon has a mechanical Turk service, meaning that you just get regular people to answer questions for you, little tiny short questions, and you answer a whole bunch of them. Turkers do that sort of thing like an income, essentially. It's a lot of hard work. And what you end up doing, you can run it full experiments with just people answering little short questions. And so they did this with people that were doing Amazon's Mechanical Turk. It's essentially a human acting like a machine, hence mechanical. There's a whole history behind the term Mechanical Turk. But at the end of the day, they reproduce the same results that they found for Cleveland and McGill, which is that humans, when they're analyzing, depending on the kind of data, it radically changes how we interpret the data. So if you use position and the two columns are aligned to one another, we're extraordinarily good with this. If I have two stacked graphs and they're both at the bottom, you're pretty good at it. If I have a stacked graph here and here, not so good. And if they're in different places, they're aligned here, you're pretty good at it. If they're in different places, you're pretty terrible at them, right? If you're recognizing the rectangular area and they're not aligned to one another, you're terrible at it. There's a bunch of different things, ways and combinations of these things. It's well established, and when I'm working through your project with you guys, I'm going to be giving you this as feedback, just in case you're a little bit off. For the most part, though, position is extremely good. So in terms of a magnitude, in terms of ordinal data, in terms of continuous data, position on a common scale is best. Position on a line scale is not as good, but it's okay, I guess. The length is pretty good, tilt and angle. As you're going down, it's getting worse and worse in terms of the evaluation, but it's still not bad. Notice color and luminance, it's okay for showing magnitude or scale or ordinal data. Ordinal data is, they're about the same for both of these things, but they're not as good as using position on a common scale, for example. Volume, you would think would be good, but no, we're really terrible at it, right? If this is a false three-dimensional, you make a three-dimensional shape on a two-dimensional screen, so you don't actually see three dimensions at once, you only see two dimensions, and we're really bad at judging that amount of volume. The size of the shape on your retina is different than your interpretation of the size of that shape in your brain. So we're not really good at this. We're not very good at figuring out the amount of curvature on something. Pointillization is not particularly great. Here's for categorical data. We have where it's positionally spaced in a region. Then we have hue, like colors of the rainbow, not saturation. This is the amount of red versus red, yellow, green, blue. All right. We have motion that can categorize. The two things that are moving, you will think are in the same group. The three things that are moving in this way versus the other stuff, you will consider those in the same group. The shape, if the two items are the same shape, you will consider them part of the same group. You do this naturally. Everybody does. But this is normally really good for categorization. Here's the wild thing, like I pointed out last time. Across the top, for quantitative data, for ordinal data, for nominal data, in all three of these cases, position is king, queen, whatever you want to call it. Position is key. The position is the best thing we have for reading off data. Which leads us to what we're talking about today. If position is always the best, what do you use it for? How do you choose what dimension to show there? There is a limited amount of stuff you can show at any given time. There's a limited amount of data you can give somebody. If you give somebody a report, what do they read? They will read the first paragraph. So imagine really easily distracted person, maybe someone in the White House right now, right? What do they read? They read the first words. They look at the pretty pictures perhaps. If you're reading a book, you look at the pictures first, right? If there's pictures in your books. Or you might look at the back cover first. You might look at the picture on the front of the book, right? What is the first thing you get? What is the takeaway? If you have a limited amount of time, because nobody has enough time to look at all your visualization and really read every single word you say. They will not do it. Then the question is, how do you prioritize? That's the summary for today. So that's why I prioritized for today. How do you prioritize is the priority for today. Okay, so we are going to be looking at tasks, what the person is trying to do, what the user is trying to do with your system. You may not always know what the user is trying to do, but that's your job, is to find out in advance. We'll look at the difference between high, medium, and low level classifications for what the task is. We'll look a little bit about that. And then we'll begin practicing classifying tasks. So, but the one thing I really am going to beat to death is, how do you know the task? How do you make sure you get it right? And why do you need to make sure you get it right? So, this is the iterative three-part or three-prong process from Tamara Munzner's textbook. It's one of our optional textbooks for the course. The idea is, if you figure out these three pieces, you can break down any visualization task, but also data analysis task, into three different parts. And when you figure out those three parts, then you can iteratively do it over and over again, getting closer and closer to an ideal solution. As part of the design process, you need to identify these three things in order to get it right. And if you don't identify those three things, it's a shot in the dark that you get it right. You could, but it's not very likely. It's just random chance at that point in time. So, what data is shown, right? The what. What am I trying to do? What is the data being shown? What is the application domain? That sort of thing. This is normally the data set that you have. This is the stuff you'll get from some online source. You'll get it from a survey, whatever the case is. And you're trying to explore, what is the data shown? What are you trying to do? Like things you can do with the data. That is very different than why are you analyzing the data? Why are you viewing it that way? What are you trying to get out of this system? Now, when we do a data analysis test in I think homework 2, we're not actually going to do it. The why are you analyzing the data? It's because I told you to. This is actually my area of expertise, and probably why I'm beating this topic to death here. My area of expertise is the why, the motivational factors for why people use visualizations. The reason I'm looking at this is because if it's not your job to analyze it, I look at casual visualizations, or I used to. If it's not your job to visualize data or to look at visualizations of data, why the heck are you doing it? And we're trying to figure out, is there something distinctly different? That's what I was trying to do, at least. Is there something distinctly different about casual visualizations compared to other visualizations? It turns out there's not much, but there is a different model or different way. I proposed a model for how you can evaluate and analyze if people are going to actually pay attention to your visualization, why they're looking at it. So, why are they looking at it? And then, how is the data presented? How are you going to interpret? Because the actual presentation of the data, if you just give a bunch of numbers, like a wall of numbers, not in a table format, just a wall of numbers, how are you going, so you can present the data that way, are you going to get anything meaningful from it that way? How it's presented ultimately tells you how effective it is at getting someone to understand the data. So even if you know their task, and you even know what the task and the data are, the presentation can sort of screw up all of that. If it's not presented in the right way, no one's going to read anything that you do. So that's the other part. That's the thing people make fun of HCI for oftentimes, which you shouldn't, by the way. The how is it presented? It's not a matter of like, oh, do I think it's user-friendly? Oh, do I like that color? It is, how do I present it so that the information that they need to take away is, sort of a slap in the face. It's obvious to them. So what, why, how? And once you get that down, you release some kind of system, you see what people do, and you get what, why, how for that system that you used. And then you improve your system. And then you get what, why, how for that system again. And you iterate over and over again, exploring how this system solves the problem and why it doesn't, or why it doesn't. So not really a what data it is, but let's look at, just say, the iPad. The original iPad, I did not know why anyone would buy that thing. I didn't watch the original keynote, so that's probably why I didn't quite get it. I fully admit I did not fully get the original iPad. Like, why are we using it? Well, you already have a computer. So the what is it was a thing that was not clear to me. It's a media consumption device. Why are people using it? Because they want something very both lightweight and simple to use for media consumption, because they don't want to have to figure out how to log in and, oh, I don't have this driver and this and that and the other thing. They just want to watch a movie on a bigger screen. And how are things presented? How do you end up using this system so that you can understand what they're doing? I'm bringing up the iPad because there was another loop in the process. When they released the iPad 2, they found out, people wanted to multitask with their thing. They would have multiple apps open at once, which they didn't support in the first one. Why are they using it? They leaned heavily into the media consumption. They stopped worrying about the reading. No one wants to read a backlit screen on an iPad. It hurts your eyes. Well, some people do, but I wouldn't be caught dead reading on that thing. And also, they found out that people wanted to take photos with this thing, and they swore up and down, no one will ever take photos on an iPad. And then you go out to the Grand Canyon, and what do you got? You got people with an iPad doing this kind of thing in the Grand Canyon, right? It looks ridiculous, but people, knowing why people are doing something, they had a device that could take a photo. They didn't have their phone on them, or their phone was put away somewhere else. Why not use the iPad? Or maybe their eyesight's not as good. And how, now I need to change how the iPad is designed to make it work in a more seamless way. And you repeat, and you repeat, and you repeat. So we will be looking at data abstraction, task abstraction, and then visual encoding of the data. That could be also text-based visual encoding if you don't use visualization. We're looking at task abstraction today. We looked at data abstraction yesterday. So here's our data abstraction. We looked at what kind of attributes, what kind of data sets, different data types. All of that is part of the what the data is. Not only can you describe what the data is from a sort of objective, it is sledding data in Ottawa, but what does that mean? Can we categorize it, and can we abstract away what that actually means? Because if we figure that out, we can actually figure out, we'll get to visual encoding in a second here. If we can figure out what the data is, then we can have tools that solve the more general case. I don't want to make a visualization that only works on sledding hills in Ottawa. I want a visualization that works with any data of this type, of this format. And I can tweak it a little bit for sledding hills in Ottawa, but if I wanted to look at sledding hills in Ottawa versus bike paths in London, England, versus restaurants in Boston, they all sort of have the same kind of flavor to them. And therefore you could have one system, you put in different data, different results come out, you didn't have to code anything new. It just works. That's what we're aiming for. So abstracting away the ideas means that you can apply the same technique to different fields in different areas as long as their data matches. Okay. So we looked at data abstraction. We're going to be looking at data encoding eventually. We're going to be looking at how data is stored, analyzed, but we got to look at how data is stored and analyzed first before we look at how it's encoded. That's going to be like the last half of the course, is looking at visualizations and how we actually perceive and interpret data. It relates to every part of the course. It's more human-centric than just say machine learning, but I also want to look at data, information, and storage. So that's for upcoming lectures. And really later in the semester, really at the end, is just not only how do we encode information, but how do we manipulate it, how do we have multiple views of the same kind of data, how do we filter and aggregate in data, that sort of thing. But let's look at the abstraction itself. So the why. So why do we abstract our data? Because what we don't want is a domain-specific terms and the like. You don't want to reinvent the wheel. The whole field of visualization is we can learn something about visualizations that we can then apply to biology so that biologists can analyze their data better. Or if it's applicable, it can apply to physics. Great. It can apply to the stock market. Great. What I don't want to need to have is be a stock market analyst in order to make a visualization about the stock market. I want to abstract away the very concepts and so that I can apply it to a variety of different fields. This is one of my favorite quotes, and notice the asterisks in there before you start yelling at me. So, I'm not sure how many of you have read this quote. If I asked people what they wanted, they would have said faster horses. And it's supposed to be a quote from Henry Ford. That's where the asterisk comes in. It's not a quote from Henry Ford. There is actually no evidence that Henry Ford actually said this. It does correspond with Henry Ford's attitude about things, and that's where I like to talk about it. So he may never have said those famous words, but from all of his behavior, he seemed to have believed in those famous words, even if he didn't say it. If I asked people what they wanted, they would have said faster horses. Not a car, they would have wanted faster horses. The user doesn't know squat. This is normally the cudgel that people use to beat on you, to say, you can't ask the user, they will tell you whatever they want, right? The user doesn't know. It takes genius to figure out what the user wants. I'd also like to point out a Henry Ford quote that is true, which is, you can have your car in any color as long as it's black. Henry Ford had like 60-70% of the American car market when the Model T came out, and when the first number of years with the Model T, and by the end of the 1920s, early 1930s, he had 25%, 30%, something like that. All his competitors realized that he was completely missing out on a large swath of user demand, like the color of the car, different models of car, it slowed down the assembly line, but he was not right for all time. He mixed together a whole bunch of innovations together, but he was not right at all the time. I would also add to this, the user would say that they wanted faster horses. They'd also want horses that don't die. They would like horses that do not need to be fed, that didn't poop on the ground, that could run really, really, really fast, pulls a whole bunch of people all at once. You wouldn't have to worry about this horse being spooked if it got stung by a bee or something went in its way. Things like that. Maybe a horse that doesn't, maybe if your carriage didn't have a horse at all, maybe that would be even better. Yeah. The user doesn't know what they want per se. They know their pain point. It's your job to figure out what their pain point is. So you do not say, what do you want for this visualization? That's stupid, right? Sorry. Your job is to figure out what they need, what they're trying to figure out about your system, and then build the visualization around that. You figure out their needs and you build around that. You don't ask them what they want. That's the difference. And that's what when we do this interview at the end, for project 2, I do believe, you're not trying to ask me what the answer should be. You're trying to figure out what the pain point is so that you can come up with the answer. That's what we're looking at. Okay, so why do we understand the task? Well, that's a pretty good question. It permits task abstractions. So if we know the task, we know how it gets applied, or what tools we have available for that particular kind of task. If I'm comparing 2 different line graphs, what do I need? If I'm comparing presidential polling over time, what do I need? That's the same as looking at stock market prices over time. It's a very similar task. It allows us to prioritize our efforts, which is a lot bigger than you might think. You have a limited amount of time. We'll go over each one of these in turn. You have a limited amount of time, though, and what is the key part, the thing you need to land? So the Remarkable 2, or the Remarkable, it's a digital paper tablet. You can look it up. It's called remarkable.com. It is essentially an e-ink reader, like a Kindle, but you can draw on it. You can write on it. It has a pen. The one thing that they needed to get right was that it's like paper. I loved my old Remarkable. I still want to buy another one, because they figured out what they needed to do. They had to do one thing. They had to nail one thing, and that they did a whole lot of things wrong. Right? Their interface was garbage. They got paper writing down. It's like drawing on paper, and that's all I ever wanted. I pull up a PDF, I can draw on the PDF, and it writes like paper. Not sort of like paper, it writes like paper. I don't know I'm writing on a pad of paper hardly compared to this thing. That's what they prioritized. You focus on, you have a limited amount of attention from the user. You need to focus the user. Not just focus your efforts, but focus the user. You don't want to solve the wrong problem. Everything's always more complex than it seems. And so to figure out, to really understand something, you really need to deep dive into it. The task dictates the needs. I think there might be another one. No. So depending on what your task is, it will tell you what you need to do. So here's a bunch of visualization tools. Why so abstract? This is the thing. I'll make a lot of generalized visualization tools. An extraordinarily general one is D3. It's a JavaScript toolkit that allows you to make pretty much any kind of visualization that you want. But you have to roll yourself. Like, it gives you some things to do, but I remember doing a visualization course about 2 years ago. We asked people to do D3, and people freaked out about it. It was just way too hard for them, especially if they hadn't done D3 before. More specifically, Tableau was what we're going to be doing. Much easier. It is still fairly general, but it's about, if my mouse is here, about here on this specific to general case, right? You cannot do everything under the sun, but you can do a lot of things with Tableau. It's relatively easy to do. You can get it to almost give it to anybody. GFI, I'd guess it would be pronounced. ArcGIS. These are ArcGIS is a GIS system. It's a global it is a global positioning or a mapping system. GIS. I gotta look at what it stands for. It does maps in particular. Maps of the world. It is not a general tool like D3. It is still very, very powerful, but it's very specific to maps. And depending on what you need, it will give you different tools. And then you could talk about things like, I guess this is MATLAB down here, or any kind of molecular visualization stuff that you would have. JMOL for Java molecular visualizations. All right. We need to figure out what the task is, and if you make it really, really general, it makes it hard. It will presumably, and actually does, it makes it more complex, and it doesn't give you the same kind of bang for your buck in terms of productivity gains. But if you make it too specific, then you have to, if it's too specific, it may not solve the problem for a lot of people, and the people it does solve the problem for are a much, much smaller group of people. But it might be easier for them. So, here we go. Prioritizing efforts. Anyone know what this is? You can't say anything right now, so let's see if you recognize it. You might recognize it now because it showed up in a movie recently. Yes, that's a Zune. The Microsoft Zune. It's one of those things. I talked to Bill Buxton about this past fall. He's a big name at Microsoft Research. He's a huge, most published Chi researcher of all time. He actually loves the Zune, and I pointed out, it might have a lot of stuff going for it, but it doesn't do the thing it was designed for. It had it had wireless connectivity, and it really allowed you to share things with other Zunes, and it did this, and it did that. It did your taxes for you. There was all sorts of cruft. They added everything on this thing. And of course, as a result, the battery life was garbage, right? And figuring out how to use this thing was garbage. The cruft all the extra stuff that they added to the product did not help sell the product. Your time was, your time and money is limited. You can add a whole lot of features all you want, but what is this for? It's for listening to music. What should it do? Help you listen to music. Everything else is secondary. So get rid of everything that you don't need for the first pass, or at least get rid of most of the stuff. If you put something in there, it better be high priority, because the high priority things have to be nailed. You have to make sure that they're dead on. This also leads to something called minimal viable product. Many of you might already know about this. The idea, we talk about it in different terms when we talk about programming, but it's the same concept. The first thing you do is you try and get something out the door. It doesn't have to be in the market. It doesn't have to be available to consumers, but you want a proof of concept that this thing will actually work. A minimal viable product or a minimal viable code product, right? Minimal viable interface will do that. What we want is something that we can think about, explore the ideas, explore how the design works, explore how we want to analyze our data, and then figure out what went wrong, and then build from there. Don't build everything and then figure out if it works. It's an iterative process. And that's why we have so many parts to our project. We don't have a project that's just due at the end. We are doing designs, and then I give feedback. And then you do a higher fidelity design, then I give feedback. And then you start coding the back end, and I give you feedback. And then you start coding the front end, and then I give you feedback. And then you evaluate it against your peers, and then you get feedback from your peers. And then, yeah, over and over again. That's what we're aiming for. Because you don't know, even if you know what the task is, you can be a little bit wrong, and it's your job to correct course when you find out you're wrong. So it allows you to, but the figuring out the task is how you prioritize your efforts. What is the thing that you have to nail? And that's the thing that you can just decide what is in your minimal viable product. If it doesn't solve the task, it's not part of the MVP. Once you have that, then you can see if it works. Okay. Users' attentions are... I probably should stop the video and let you take a break because people's attentions are really bad, right? And feature creep has been something that people now fight against, but in the late 90s, early 2000s, it was brutal. Every single thing, every piece of software tried to be everything to everybody at all times. And I can't remember the exact numbers here. With Microsoft Word and the like, it was something like 90% of Microsoft features were not used by more than 10% of the population. So the vast majority of people were using like 10%, like over 90% of the people were using about 10% of the features. And the rest of it was just there. I mean, how many of you have used a macro in Word? I mean, I have, but I don't know that many people that have, right? It is when you start, they start adding more and more features all the time. If you try and support all those features, you do not have time, and the user doesn't know where to go. So there, find and replace. Find subscript in there. You are hunting in a pile, a somewhat unassorted pile of icons. Arranging your icons is one thing, but just if you have too many options, too many features, people don't know where to look, and where they just give up on knowing where to look. More options mean more confusion. And I have a recent story of that from this past week. So for CU Learn, for my Bit 2400 class, I went, okay, I don't have all my assignments done. I better hide my assignments. So I then go and I hide all my assignments on my students so that they don't see that the due dates are wrong. What I don't know is the due dates automatically still go to the users, so my students, so they're seeing a due date for an assignment in June when the course starts in September. Holy crap, people start freaking out. So I go and fix all the dates. And then find out that they don't even see the assignments. So I set the assignment right, and then they go, where's assignment 1? And then they start freaking out about that. Why? Because I had still hidden the assignments. I forgot to unhide it. Why? Because there's too much crap on CU Learn. It's this big wall of text and buttons and things, and it's hunt and peck to find out how to do something. It wastes so much instructor and TA time. It's really shocking. If it's not designed correctly, people will not be remotely as efficient, or they'll be wrong. You want to make a simple interface, or at least you want to make it as simple as possible to focus their attention to what really matters. If they want to look at the other data, fine. But the thing that pops out at them when they're looking at the data, that's what you're aiming for. The key takeaways. Your attention is always limited, and you will ignore stuff. You want to make sure that the stuff that the person ignores is not the stuff that's important. So, for example, I love to point this out. What is the hotkey for a numbered list? Turns out there's a hotkey for a numbered list. Right? Why would you need to know this? Well, my son knows it for some reason. And just because someone can use it doesn't mean it's necessarily useful. So hotkeys are a good example where you don't have to memorize it. You don't have to use a hotkey. It's available at least. Great. But if just because it's there does not mean people will use it, and therefore you're pulling away the attention from the main task. In the case of Word, the main task is writing a damn document, not figuring out how macros work. And so what you really need to understand is how people's workflows. So if you know what their workflow is, you can take something that's really complex, move stuff that's rarely used into a less high priority or high visibility place, and keep the stuff that they're doing all day, every day, right up front. Right? That's what you're aiming for, to try and take the biggest things, pop it up front, all the minor stuff, put it to the side, or make it less visible. That's what your visualizations or what your system should be doing as well. Right? No one's going to go through and look at every line of whatever report you do. All right. Okay, so next, do you know what the hell this is? Does anyone know what this object is? I have one in my office, which I can't get to right now, but it's in my office. Yes, for the one of you, maybe, probably not, that know what this was, this is the Nexus Q. This is actually the precursor to the Chromecast. Weird thing about the Nexus Q, though. I saw it, I went, whoa, and then went, whoa, when I saw the price tag. This thing costs $300. What's interesting about the Nexus Q is they released it at the same time as the Nexus 7, which is the first 7-inch tablet that Google made. It was a huge hit. The Nexus 7, the tablet, cost $200. This thing cost $300. This thing required you to buy Google stuff, either movies or music, from Google. You could not play your own music. You could not play your own movies. It cost $300 to be a stereo system that could only play Google products. And the moment that Sergey and Larry figured out what they were selling when this came out, they realized, oh, no, no one's going to buy it, and we are not doing the right thing. They were trying to force the user they were trying to make the user do what they wanted, not give something to the user. They were not solving the user's task. They were trying to coerce the user into using their system. It's the wrong solution. They're solving the wrong problem, because that's not what the user ever wants, and no one's going to pay $300 for it. The interesting part of this story is if you pre-ordered the Nexus Q, they gave it to you and refunded your money, because they were like, nope, we're not selling that thing. And so having one, I can't use it, but I love the fact that I have one. It's a constant reminder of you're designing for the user. So for me, things like Twitter made no sense initially, right? Why the hell would anyone want to listen to my ramblings about whatever topic it is? No one does. My friends might, and that's really, once you start realizing what people are using Twitter for, either there's celebrities spamming everyone and people trying to find out what's going on with those celebrities, or I'm talking to friends and I'm just trying to give them a blast message of what's going on in my life, or it might be coordinating and communicating information to everyone while, during a revolt or during a revolution. All actual uses for Twitter, by the way. But they're not what originally people were sort of saying Twitter was for. That everyone's going to be on Twitter and they're all going to tweet at each other. No, they're not. They don't actually. You know people, or you're a celebrity and then you spam everybody, but no one wants to know about your cat. So Snapchat's the same thing. Why would anyone want to lose their photos after a certain number of time? Oh, because you might be taking incriminating photos, or it might be a photo of your friend. Since everything was being stored for all time, and you're a teenager, having something that gets rid of your photo after a couple hours or a couple days, that's actually a pretty cool idea. It flies in the face of what we normally associate with, taking photographs. And it speaks to this concern about permanence and things being held against you later on. You can't force the user to your system. Your problem is to solve their problem. That's what you're trying to do. So I'm going to take a brief break after this obligatory comic, and then we'll get to other newer things about tasks. All right, you can pause it and read the video if you want. Thanks. Thanks, everyone.